we're going to start looking at some of the solutions to this function worksheet. Um, this first part, they should not be a big deal. Okay, you should perfectly understand what this notation implies. G of 9, take 9, plug it in G. Okay, 9 squared is 81 times 2. Okay, 162, and then 162 back in there again. Just do the work. Okay. Um, Here, part 2 is the decomposition of functions. Okay, so whereas in part 1 we're looking at composition of functions. Okay, we know what results when we put these two together. Okay, let's just do this again, and just for illustration purposes. Okay, f(g) of x is a new function. Essentially, it is 2x squared going in for x being multiplied by 2 and then adding 5. So the decomposition would say, oh, 2x squared is the g of x and f of x is that. So the same thing down here. Okay, this h of x function can be expressed as a composition of two functions. There's not just one way of doing it, but this is just one example. So if the inner function is 4x plus 1, call that g of x. The outer function will be the root, and you can check that composition itself. It will give you that. And the others should follow the same pattern. Okay. The iterations here are worth mentioning. Okay. So if we look here, this one, the 10th iterate of x squared. So it's f of x is the first iterate, and that's x squared squared, which is x to the 4th. Okay, or x to the 2 squared, if you will. Okay, the second iterate would be taking the result of that and feeding in the original function, which is x squared to the 4th power, which is x to the 8th. X to the 8th is 2 to the 3rd, and I write it that way because the second iterate is x squared raised to the 3rd power. So the 10th iterate should be x squared raised to the 11th power, or in general we can say it's x squared to the power n plus 1. And okay, so the 10th iterate n being 10, we would then have x raised to 2 to the 11th, and 2 to the 11th power is 2048. Okay, moving along. Okay, for some other examples. All right, here the composition of functions needs to be mindful of the domain that is determined as a result of the composition. So g of h of x is easy enough to do, but remember this: the square root of x squared is by definition the absolute value of x. We showed you that on the calculator. You should check that for yourself. But when considering the domain, we've got to consider the innermost function, h of x. Its domain is x squared. X squared has no restrictions. And then we do the composition, okay? And in the composition, the end result is absolute value of x. And we consider its domain unto itself, which is, again, all reals. But and then the intersection of the two domains is, of course, unchanged at all reals, negative infinity to positive infinity. For illustrative purposes, though, I think it's best if we look at the composition the other way around, the hg of x. hg of x. So that is to consider x squared going in for x here. So now the composition of functions there is the square root of x squared, which is x, or absolute value of x. We're going to see that why it actually collapses to x is because of the domain. So let's take a look at that. So we consider g of x the innermost function. That's restricted, only defined for well, I guess we could include 0, so we should actually include from 0 to infinity. Okay, the overall composition netted us x or absolute value of x. Again, either one is going to state that the domain for this unto itself is all things. But then, okay, we consider the union between all the non-negatives, that's from 0 to infinity, not the union, I'm sorry, the intersection between that set and the domain that we get from absolute x or from just x, which is everything. Their intersection is just the non-negatives. Again, we're going to include 0. I'm sorry about that. We can include 0, okay? And again, we illustrated those on the calculator. You should, again, check that for yourself, okay? These sets of functions are all inverse functions, okay? With the exception of that one at 5, which we're going to show you what happens with that, okay? So, and of course, with inverse functions, the composite taken f g of x and the composite taken g f of x should equal each other, and it should in fact equal x. Okay, so you know when you're right, you're collapsing that to x. I considered D, even though I said there was a typo there, they were not inverses. It's well worth looking at. Okay, so the f g of x composition says again all of g goes in for x right here in the numerator, so we get that's what used to be x, which is now g, minus 5, and the denominator, this which used to be x, is now all of negative 2x minus 5 over x minus 1. You guys just keep having problems with fractions, and there's really no reason. It's fractions. This is a complex fraction, a fraction within a fraction. Okay, so to that extent, we have to put these on a common denominator. The denominator is x minus 1. So we express the 5 with the denominator of x minus 1, which means we need to modify its numerator as is demonstrated here. Okay? Also, in the lower part, we need to do the same as well. We need to put these terms on a common denominator, okay, which is x minus 1. Okay, which means that the 1 minus 1 is now minus 1 times x minus 1 over the common denominator x minus 1. Invariably, this is of the form a over b over c over d, okay, which is the form of a improper fraction, which ultimately becomes a over b, okay, times, we invert and multiply. That's what I said over here. Improper fractions invert and multiply. So it's a over b times g over c. And we can see our d and b terms are the same here, x minus 1, x minus 1. So they're going to cancel out. And it's just going to leave us this expression in the numerator here, which will carry out the distributing of the 5, and in the denominator, that is carrying out the distribute of the negative 5. Be mindful of that distribution, okay? And then in the denominator, the same. We'll tie our terms together, and this is what we get, okay? So that's what we get, and I'll leave it to you to do the composition the other way, and I can assure you it will not be the same thing, because these are not inverse functions, so it is for you to determine that, okay? We're going to end this session here, come back and talk about the other half on the next video.